Hey everyone, my name is Monique Mazerel. I'm a fourth year nursing student working with the University of New Brunswick in St. John to create some peer-led tutorials or webinars on medication math. So today we're going to be focusing on reconstitution. At the end of this video, we want to be able to calculate the milligrams per mils of a medication based upon reconstitution of these medications. So to start off, what is reconstitution? What does that even mean? If you've never heard of it before, it might sound confusing. So sometimes with medications, they come in powdered form. And if they come in powdered form, we have to add a diluent to the powder to give that medication. So it could be normal saline, it could be sterile water, but we have to add that to it to get the drug. Also, we may have to add a concentrated amount of the drug to an IV piggyback bag, which I have here, so that we can give the medication IV. So we need to know the amount of drug per mil to administer the correct amount of concentration. As well, when we add it to an IV bag, if we ever have to stop a solution, an infusion, we want to know how much of the medication has been given based on the amount of mils that have been given. I know it sounds confusing, but it will make a little bit more sense as I move on in the video. So to show you what I mean by powdered medication, I just have a picture of some Practi powder here. So I don't know if you can see it, but there is powder in there. And on the back, if you turn it over, you can see how much you have to add to get a certain volume and a certain strength. So it varies depending on the route that you're giving it or what you're doing with it. So you can see that if you want to have 300 milligrams per mil, you're going to add 9.6 mils of your diluent, whether that's sterile water or normal saline. And when you add those 9.6 mils, your new volume within this vial is going to be 10 mils. So there's 10 mils that you can withdraw there. So let's move into a question. So we have 1 million international units of penicillin in a powdered solution, and our order that we want to give is 300,000 international units IM. So the back of our medication is reading to add 1.8 mils of sterile water if we want to have a concentration per mil of 500,000 international units. And if we do that and we add the 1.8 mils of sterile water, our withdrawable volume, again, so the amount that's going to be within the vial, is 2 mils. Or our other option is to add 3.8 mils of sterile water. We'll have a concentration per mil of 250,000 international units, and our withdrawable volume will be 4 mils because we've added that 3.8. So which one are we going to use? So with IM medication, we would like to give the smallest amount possible. It's going into a muscle, it hurts. Why would we give more if we can give less? So let's do our med math here. So since we're going to be giving a smaller amount, we are going to go with adding 1.8 mils of sterile water to our concentration so that we have 500 international units per mil. So you can see here that I've drawn up 1.8 mils of sterile water, and I would be injecting that into my powdered medication. So again, I just have Practi powder here, but once you add it, you have to mix it up, roll the vial gently between your hands, and this is what it's going to look like. So now that I've added the 1.8 mils of sterile water, I now have 2 mils of withdrawable fluid in here. That's what that means. So if we want to give this medication, now we have to do the math. So we're going to go with our formula, D over H times Q. So for D, that's our desired. We know that we want to give 300,000 international units of penicillin. We have our have quantity. And with this, you can either use your 500,000 international units per mil, or you can use your 1 million international units per 2 mil. But I like to break it down to the most basic. But again, it's preference. So what we have is 500,000 international units, and our quantity is 1 mil. So let's write this all out. So we have 300,000 international units in 500,000 international units times 1 mil. So if we do our math here, we can see that we are going to give 0.6 of a mil to create the 300,000 international units. And again, if you just take a step back and look at the question, you know that it's 500,000 international units per mil. You know you're giving 300,000, so you can immediately tell that that's less than a mil. So if you get over, something's gone wrong with your math. So how about I show you the other way here now? So we could have also, the exact same thing would happen if we were doing 300,000, which is what we want, our desired dose, over 1 million international units times 2 mils. So if you didn't want to have that broken down, you could do the same thing. And again, your answer is going to be 0.6 mils. And one more way to show this, because people are different learners. If you don't want to do your D over H times Q, you can just simply cancel out your units. So that would be over, we can do the 1 million international units per 2 mil. So this is just, again, canceling out units, and your answer is going to be the exact same either way. So 0.6 mils is what we're going to be administering. All right, so now that we have that under our belts, let's look at another question. So our order is for 200 milligrams of drug X. We have 500 milligrams of drug X in a powdered solution. And the back reads to add 7.8 mils of sterile water for injection, which will lead to an 8 mil total volume. So let's calculate the concentration per mil. So with that, we know that we have 500 milligrams of our powdered solution of drug X. And we will have 8 mils once we add in our 7.8 mils of the sterile water. So that means that our concentration is going to be 62.5 milligrams per mil. So now we want to know how much we're going to administer. So with this is our basic calculation, D over H times Q. So what do we want? We want to give 200 milligrams of drug X. What do we have? So we have 62.5 milligrams per mil, 1 mil. And when we calculate this out, we see that we are going to be giving 3.2 mils to equal 200 milligrams. So that's that math. Along with that, we don't have to put our concentration per mil. You could also just leave it as, we want 200 milligrams over 500 milligrams per 8 mil. So again, this is our D over H times Q formula. And the answer would come out to be the same. We would be giving 3.2 mils. So that's just a couple different ways to do it. The next part of the question that I'm going to do is sometimes we need to know how many milligrams are within a certain amount. So for this one, we want to know how many milligrams are in 4.5 mils. We know that there is 62.5 milligrams per 1 mil. So we can simply cancel out units. So we have 4.5 mils. And we know that we want to end up with the milligrams. That's what we're looking for. So we have 62.5 milligrams per 1 mil. And if we calculate this out, our answer is going to be 281.25 milligrams. So you could round that up. You would know that you have approximately 281.3 milligrams per 4.5 mil. So that's just another way. I mean, it's taking the same information, it's kind of changing around the formula and just getting more from it. We'll move on to our next question. So we have an order for 250 milligrams of ampicillin sodium. We are going to add 1.9 mils for injection. Our total volume will be 2 mils once we add this. And if we want to do it IV, we're going to add 5 mils. So what's the concentration per mil for each? So if we're doing injection, we want to know how many milligrams per mil. So we're going to take that 250 milligrams. And it's simple math. We're looking for milligrams per mil. So we can just simply put the milligrams over the mils. So we know that there's 2 mils total. And if we do that math, we can see that the concentration is 125 milligrams per mil. Then, if we want to find out the IV solution, if we're adding 5 mils, it should equal out to be 5 mils. So we want to see 250 milligrams divided by 5 mils this time. And our answer is going to be 50 milligrams per mil. Okay, so next up, so we've added our 5 mils to equal our 50 milligrams per mil, 250 milligrams total within that 5 mil vial. So if we add this to a 100 ml bag, so what I showed you earlier, because we're going to be giving it IV, we want to know how many milligrams we have per ml within that. So what we have to do is you have to keep in mind that we're adding 5 mils of a solution to this bag. So the total amount of mils is going to be 100 plus 5, which is 105. That's how many mils are going to be within this bag. Again, we're looking for milligrams per mil. So we have 250 milligrams, and we have to divide it, like I said, simple math, milligrams per mil, so you're literally dividing the milligrams per mil, so 105 mils. And when you do that division, your answer is going to be 2.38 milligram per mil. And like I said, this is really important to calculate out in case you have to stop an infusion. That way you can recognize how much of the medication has been administered to the patient. So that's Reconstitution in a nutshell. I hope that you found this video helpful, and I hope you continue to watch more.